All right, so for this week's problem of the week, I decided to do number one on the PDF Professor Pattingale assigned to us. And number one asks us to find the general solution for the differential equation x squared y double prime plus 3xy prime plus y equals 4 ln of x, given y equaling x to the negative 1 as a solution. Now, given that we were given part of the solution, this immediately points to reduction of order. So I'm going to go with that pathway to find a solution. Now, reduction of order says that y1 is equal to the solution given. Cool, halfway there, sort of. And y2 is equal to u times y1, which is x to the negative 1. Now, in order to figure out what y2 is with the differential equation, we need to take two derivatives of y2. And y2 prime is u prime x to the negative 1 minus u x to the negative 2. And then the second derivative of y2 ends up being u double prime x to the negative 1 minus u prime x to the negative 2 minus u prime x to the negative 2 plus 2u x to the negative 3. All right, and these just need to get plugged back into this equation right here. So we end up with x squared times y double prime, which is u double prime x to the negative 1, is 2u prime x to the negative 2 plus 2u x to the negative 3 plus 3x times y prime, which is u prime x to the negative 1 minus u x to the negative 2 plus y, which is u x to the negative 1 is equal to 4 natural log of x. We distribute on the left side u double prime x minus 2u prime plus 2u x to the negative 1 plus 3u prime minus 3u x to the negative 1 plus u x to the negative 1 equals 4 natural log of x. Alright, now with these values of u x to the negative 1, if we combine like terms, we end up with 0 values of u x to the negative 1. So those cancel. And if we combine the like terms, we end up with u double prime x plus u prime equals 4 natural log of x. Now I'm going to do a quick substitution to clean this up a little bit, and I'm going to substitute w for u prime. So w prime is equal to u double prime. So w prime x plus w is equal to 4 natural log of x. If we divide by x on both sides, we end up with w prime plus 1 over xw is equal to 4 over x natural log of x. Now this looks a lot like a first order linear differential, so I'm going to go through that pathway to hopefully solve it. Our integrating factor would equal e to the power of the antiderivative of this value right here, so 1 over x dx, which is just e to the natural log the absolute value of x, which is simply x. And if we multiply that back into the equation, we end up with w prime times x plus w equaling 4 natural log of x. So I'm not going to write that out, I'm just going to leave it right there and erase this step, because this right here is what we need. And if we pull out the derivative on the left side, we end up with d dx times wx equaling 4 natural log of x. Take the antiderivative of both sides with respect to x, and we end up with wx equaling whatever this monstrosity is. So if we do a quick integration by parts, by letting u equal the natural log of x and dv equaling dx, du is equal to 1 over x dx, and v is equal to x. Now, if we pull this down here, we end up with 4 times x natural log of x minus v du, which is x times 1 over x, which is just 1, but I'm going to leave it written like that. Solve that, wx, so 4x natural log of x minus 4 times the integral of 1, which is x. C. Now we do need our integrating constant because when we divide x on this side, x comes into play for the constant, so it's no longer simply a constant. W ends up being 4 natural log of x minus 4 plus c over x. But we're not done yet because w isn't what we're looking for. It's u prime that we're looking for, which w is just standing in for. So u prime is equal to 4 natural log of x minus 4 plus c over x. All right. And we take the antiderivative again on both sides with respect to x. Now, I'm not going to write this out, but I am going to split this up. I'm going to pull the 4 out, so we end, actually I'm going to write it out. So integral of u prime dx is equal to 4 times the integral of natural log of x minus 1 dx plus c times the integral of 1 over x dx. And since c is just a constant, we can pull that out and simplify it that way. Now, I'm going to erase part of this top portion so that I have a little more room to work with. Bring this up, integral u prime dx is equal to 4 natural log ln of x minus 1 dx plus c integral 1 over x dx. All right. Got that all figured out. Awesome. Now, I made the mistake of erasing the integral for natural log of x, so I will run through the integration by parts again, just a little quicker. So the left side ends up being u, that's nice and simple, equaling cu, natural log of x, dv equals dx, du is 1 over x, oops, clean that up a little bit, du is equal to 1 over x dx, and v is equal to x. So u ends up being 4 times x natural log of x minus the integral of 1 dx minus x plus c natural log of x, because this integral just becomes natural log of x. So u ends up being 4x natural log of x, well, 4 times a quantity x natural log of x minus, and 1 just becomes x, so I'm going to combine this value and this value, so minus 2x plus c natural log of x. So u ends up being 4x natural log of x minus 8x plus, now 4 times c would simply be another constant, so I'm going to leave that c there and rename it as c1, and note that c1 is equal to 4c. All right, so we have our u, so we can plug that back into this equation right here, y2, to get our y2. So y2 is x to the negative 1 times 4x natural log of x minus 8x plus c1 natural log of x. Now, notice I did not include an integration constant for this last integral, either one of these up here. And that's simply because when we bring that all into our final equation, some constant times x to the negative 1 will already be represented in that final equation. So rewriting it would become redundant because we could just simply combine it, rename the coefficient, and we end up right back where we started. So the final solution, given that we have y1 and y2, would be y is equal to c2 x to the negative 1 plus x to the negative 1 times 4x natural log of x minus 8x plus c1 natural log of x. And here is that constant times x to the negative 1 I was mentioning prior. So this right here is our final solution for x squared y double prime plus 3xy prime plus y is equal to 4 ln of x, given y1 being x to the negative 1 as a solution.